Welcome to Curious Minds. When you drive a car, speed is simple: miles per hour, kilometers per hour, distance over time. But the moment you step onto a ship or board an airplane, everything changes. Suddenly, speed is measured in knots, not miles, not kilometers, knots. Why does a modern jet, flying at 30,000 feet, still use a unit that sounds like it belongs on a rope? And why, in an age of GPS and satellites, are we still using a measurement that dates back hundreds of years? The answer takes us to wooden ships, sand timers, and the shape of the Earth itself. Let's untangle the story of the knot. To understand knots, we need to go back to the 17th century. Sailors back then had no GPS, no radar, and no speedometers, but knowing speed was critical. If you didn't know how fast you were moving, you couldn't calculate distance, and that meant getting lost, missing land, or crashing into reefs. So sailors invented a simple but brilliant tool called the chip log. It was a small piece of wood, weighted, so it would stay upright in the water. This wood was tied to a long rope. But this rope wasn't random. It had actual knots tied into it at very specific intervals. To measure speed, the sailor would throw the wood overboard. The wood stayed behind in the water while the ship moved forward, pulling the rope out. At the same moment, another sailor flipped a sand timer, usually about 28 seconds long. As the rope ran through the sailor's hands, he counted the knots as they passed. 1, 2, 3. When the sand ran out, he stopped counting. If 5 knots passed in that time, the ship was moving at 5 knots. That's where the term comes from. A knot is not a metaphor. It was literally a knot in a rope. But here's the real question. Why were those knots tied at such a strange distance apart? Why not 10 feet or 50? This is where navigation meets the geometry of the Earth. On land, we use miles or kilometers, measurements based on walking. A mile comes from ancient Roman soldiers counting steps. That works on roads. It doesn't work well on oceans. Sailors don't navigate by roads. They navigate by the planet. The Earth is divided into latitude and longitude. A circle has 360 degrees. Each degree is divided into 60 minutes. Sailors decided something ingenious. 1 nautical mile would equal 1 minute of latitude. That meant maps and measurements matched perfectly. If a captain needed to sail 1 degree north, he instantly knew that meant 60 nautical miles. No complicated math, no guessing. When sailors calculated how fast a ship needed to move to cover 1 nautical mile in an hour, they figured out the spacing. Knots tied about 47 feet apart, counted over 28 seconds, gave an accurate reading of nautical miles per hour. 1 knot equals 1 nautical mile per hour, and a nautical mile isn't arbitrary. It's built into the Earth itself. So ships use knots because knots speak the language of the planet. But what about airplanes? Why does a modern jet still use knots? When aviation began in the early 20th century, pilots didn't have their own navigation system. Long-distance flights followed coastlines and crossed oceans. The only reliable maps available were maritime charts. Early pilots navigated using stars, horizons, latitude, and longitude, just like sailors. Since they used nautical charts, they used nautical measurements. There was another reason too. Planes fly long distances over the curved surface of the Earth. Using flat land-based miles actually makes calculations harder over long arcs. Knots, tied directly to latitude and longitude, keep navigation simpler and more accurate. So when a pilot says you're cruising at 500 knots, that number isn't outdated. It's elegant. It connects modern flight to ancient navigation, to ropes, sand timers, wooden ships, and to the geometry of the Earth itself. Cars measure speed based on walking. Ships and planes measure speed based on the planet. If you like this video, please like and subscribe to Curious Minds for more fascinating content.